Hi folks, welcome to the second part of the Chapter 3 Key Concepts Review for Math 521B, or Pre-Calculus 11. We're looking at quadratic functions, specifically vertex form by completing the square, word problems, and we'll also sneak in factored form. There are a few disclaimers on screen. You may also want to check out the video description below because there's a link to a downloadable copy of the notes, so if you want to do the presentation along with me, that might be helpful. So completing the square is an alternate technique for converting to vertex form. Now remember from the last video, we already can convert to vertex form. We can find the x-coordinate of the vertex by using axis of symmetry, and then we just sub that in to find the y-coordinate. However, the curriculum guide does talk about completing the square as a technique, so we had better cover it. So completing the square relies on these perfect square trinomials. Some quadratics of the form x squared plus bx plus c factor into a single squared binomial. So here are a few examples of them. If I had x squared minus 4x plus 4, I'm looking for numbers that multiply to 4 and add to negative 4. And the two numbers that do that are x minus 2 and minus 2. So this one factors to x minus 2 all squared. And you could expand it out, and you find it would get you back to x squared minus 4x plus 4. Similarly, if I'm looking for numbers that multiply to 25 and add to 10, they would be 5 and 5. So this one factors to x plus 5 all squared. The last one, if I'm looking for numbers that multiply to 196 and add to negative 28, well, that's negative 14 and negative 14. Now what's special about these trinomials is that in all of them, the last term is half the middle coefficient squared. Let's see what that looks like. In this first one, negative 4, take half of it, so negative 4 divided by 2, squared. Does that give us 4? Yes, it does. Let's check out this one, negative 28 divided by 2. Or negative 14 squared. Does that give us 196? Yes, it does. The factored form, if you notice, deals with half of the middle term. So here we had a 10, a plus 10. Look at this. There was a plus 5 in the factored form. Here we had a negative 4 in the original. There's a negative 2 in the factored form. This had a negative 28, negative 14 in the factored form. That means when we have these perfect square trinomials, we can factor them quickly, as long as we know that they satisfy that condition, that the last term is half the middle squared. Let's get some practice on finding that missing last term and then factoring quickly. So here we've got x squared plus 6x plus c. If I want this to be a perfect square trinomial, I take half of the middle, which would be 3, and I square it. Here we have 3 squared. That should be a 9 for our last term. So x squared plus 6x plus 9. And here's how it factors. X, take half the middle, so half of 6. So x plus 3, all squared. The next one, we'll do the same thing. Half of negative 12 is negative 6. Square it means this should be 36. How does it factor? X, half the middle, half of negative 12 is minus 6 squared. The next one, we have x squared plus x plus c. So that's a coefficient of 1. So half the middle, which would be a half, squared, would give us a quarter. That should be our value of c. And the factoring is no more difficult here. I just take half the middle, which is a half. Next one, negative 5. Okay. Half of negative 5 is negative 5 over 2. Square it, that's 25 over 4. How does it factor? X, half of negative 5, is negative 5 over 2. Similarly, we could have more fractions involved. So half of 2/3, that would be 1/3. Square it, gives us 1/9. How does it factor? Half of 2/3 is 1/3. And finally, half of 1/5, that's 1/10. Square it, gives us 1 over 100. And I just go x. Half of a fifth is 1/10. So automatically we get these perfect square trinomials if we choose the right c value. And we should be able to factor them very quickly. That's going to be important when we go on to completing the square, which is what we're going to do right here. We use completing the square as a technique to convert to vertex form. Now, it is not my favorite technique for converting to vertex form, but it works. Okay, so here's what we do. We write out the function. I'm going to leave some space because what I'm going to do is I'm going to add and subtract that sort of magic number. That half the middle coefficient, which would have been 3, squared. I'm going to put the plus first and the minus second. So that way the equation stays balanced. I added 9, but I also subtracted 9. The first 3 terms are automatically a perfect square trinomial. So we know how they factor. It's x and then half the middle. So x plus 3 all squared. And that leaves us with minus 9 and minus 3. So we get x plus 3 all squared minus 12, telling us that this has a vertex at -3, -12. That's the technique when we don't have anything in front of our x squared. So let's practice it. Convert to vertex form. I'll leave some space after my 5x because I know I'm going to have to add and subtract something. And what is it? Well, it'll be half the middle squared. So that's plus 25 over 4 minus 25 over 4. And this is going to be much more straightforward in fractional form than in decimal form. Okay, automatically I know that these first 3 terms are a perfect square trinomial. So I just take half the middle, x plus 5 over 2 squared, minus 25 over 4, plus, I'll need a common denominator, so I'll call that 2, 8 over 4. And that gives us negative 17 over 4. Okay, so that's where the vertex is, at negative 5 over 2, or negative 2.5, and negative 17 over 4, or negative 4.25. Trying it again over here. So half the middle would be negative 3/4. Square it. Gives us 9/16, which I'm also going to subtract. Always the plus first. These first 3 terms automatically are going to be a perfect square trinomial. So half of negative 3 over 2 is negative 3/4. I have minus 9/16 plus 1, which is 16/16. By the time we're done here, we have plus 7/16, or a vertex at 3/4, 7/16. Okay, now we'll decide how we do it if we have something in front of our x squared term. So if we have an a value, where this is a, b, and c, that is not 1. So step 1 then becomes to factor out 2 from the first 2 terms. So I'll have 2, and that's going to leave me with x squared plus 4x. Okay, just removing a common factor. And I'll have a plus 9 at the end. From here, we'll proceed as usual. So what do I need to do? I need to figure out half of the middle, which is 2, and square. And that's going to go in within those big brackets. So I'll have plus 4 and minus 4. These three terms are a perfect square trinomial. So they're going to factor to x plus 2 all squared, leaving me with a minus 4 and a plus 9 out here. Finally, I'll multiply in. And this 2 is just going to become a coefficient for that bracket. It tells us about our direction of opening and steepness. 2 times negative 4 would be negative 8. Plus 9 gives us this. Now you might notice this is the exact same trinomial that we did at the end of the last video. So again, this is one technique for putting things in vertex form, but it's not the only one. Use whatever you find most straightforward. We'll try another one of these where you have a long trinomial or a coefficient in front of your x squared. So I'll take out that 3 from my first two terms. I'm going to leave some space, and I'm going to have a plus 11. I'll do this all in one step here. So half the middle squared means that I'm going to add on 9/4 and subtract 9/4. That's going to give us 3. X minus 3 over 2 all squared minus 9/4 plus 11. And here we have some fractions to deal with. So this will give us 3. X minus 3 over 2 all squared. 3 times 9 over 4 would be negative 27 over 4 plus 11. And again, you'll need a common denominator. So that's 44 over 4. In the end, we get this. Okay, that tells us that the vertex is at 3 over 2, 17 over 4. I'd prefer to use the other approach. I'll go through it really quickly here, but you can do whatever works for you. So if you're doing the other approach, we say the axis of symmetry is x equals negative b over 2a. So that's going to be positive 9 over 2 times 3 gives us 3 over 2. So right away, I know that my vertex is at 3 over 2 something. If I want to find the y-coordinate of my vertex, I simply sub in 3 over 2 into the function. That gives us 3 by 9/4 minus 27 over 2 plus 11. Yes, we'll have to deal with a common denominator, but that's okay. And it still gives us the same value of 17 over 4. So in this form, really, we're finding the vertex so that we can put it in vertex form. The other way around, we put it in vertex form so we can find the vertex. Now, putting it in vertex form, our a value is 3. The vertex is at 3 over 2, 17 over 4, so it's going to be x minus 3 over 2 plus 17 over 4. It's the same result. I just find there's a little less to remember with that second approach, but however you want to do it. Okay, factored form. This really isn't pushed in the curriculum. But moving ahead, as you do more and more algebra, it's worth knowing. So A still means direction of opening and steepness. R and S in this form are x-intercepts. So in the equation y equals negative 2, x minus 1, x minus 5, there'd be intercepts, x-intercepts at 1 and 5. Those are the numbers that make either this bracket or this bracket 0. We also know that it opens downward and is somewhat steep. So if I wanted to sketch this without having to go through the process of putting in vertex form, here's what I know about it. It's got an x-intercept here and here, and it opens downward. Clearly, its vertex is going to be halfway between those two x-intercepts. We're at 3. Okay, and that's going to be our axis of symmetry too. If you wanted to find out the y-coordinate of the vertex, well, you'd just sub 3 for x. So you'd have y equals negative 2, 3 minus 1, 3 minus 5, and that's going to give us 8. So the vertex is at 3, 8. For those curves that do have x-intercepts, especially integer or rational ones, this can be a pretty quick way to sketch the curve. So we'll just go through kind of quickly here. If I have x plus 4, x minus 2, all by 2, we're going to show the x-intercepts, the vertex, the axis of symmetry, the y-intercept, the domain, the range, the max-min. We're going to do the whole shebang here. So what numbers make the brackets 0? Negative 4 and positive 2. Those are our x-intercepts. Now, the vertex is halfway between them. It's going to be at negative 1. And this opens upward. Okay. We want to show the vertex. So that's going to be at negative 1 something. That's halfway between negative 4 and 2. Or if you weren't sure, you could go the average of negative 4 and 2. Add them up and divide by 2. Okay, the y-coordinate of vertex sub negative 1 for x. So we'd have y equals 2, negative 1 plus 4, negative 1 minus 2. And that's going to give us a value of negative 18. So this must be at negative 1, negative 18. What else do we have to know? The axis of symmetry? Well, that's pretty easy. That's going to be x equals negative 1. The y-intercept? Sub 0 for x. There are no special tricks you need to know for that. So y equals 2, 0 plus 4, 0 minus 2. Gives us negative 16. This must be negative 16 right here. The domain on a parabola is always the set of all real numbers. The range, well, it goes down to negative 18, but no lower. So y is greater than or equal to negative 18. And clearly, this has a minimum of negative 18. That is the lowest y value it touches. There is no maximum. It goes up forever and ever. Let's do another one in factored form. We've got x by x minus 3. Sometimes people get confused by these, but that just means x minus 0 by x minus 3. So our x-intercepts are at 0 and 3. This opens upward. My scale's not great here, so I'm just going to fix that up. Okay, and that means that we've got a vertex halfway in between 0 and 3. We're at 1.5, or 3 over 2. What does that mean in terms of our y-coordinate of the vertex? Just sub in 3 over 2 by 3 over 2 minus 3. Okay, run that through. That would be 3 over 2 by negative 3 over 2, or negative 9 quarters. There are all our axis intercepts and the vertex. Now it's important to note that not all parabolas have x-intercepts and that not all quadratics can be written in factored form. Okay, finally we're going to take a look at word problems. Max-min means vertex. Whenever you see that term, maximum or minimum, think vertex. So here we've got a theater company that has 400 season ticket subscribers. The board of directors has decided to raise the price of a season ticket from the current price of $300. A survey of the subscribers has determined that for every $10 increase in price, 10 subscribers would not renew their season tickets. What price would maximize the revenue from season tickets? So when we have a whole bunch of information like this, sometimes it's nice to take a little example. So right now, what would the revenue be? It would be 400 subscribers at $300 a piece. And whatever that works out to be. 120,000. Now, if they increase the price $10, then they'll have 10 fewer subscribers. Okay, equals something. Now, we don't want to work this out with brute force. You're not given full marks on a constructed response question by using just brute force rather than an analytical approach. But this does give us some idea of what's happening. This is number of people, and this is price. We need to define some things here. So we're going to let x equal number of $10 increases. And I always want to define my variables. So from that, the number of tickets that would get sold, well, it's going to be, right now there are 400. And for every increase, there'll be 10 fewer. The price rather, that's going to be $300 plus 10 times x. So the number of tickets and number of people are really the same thing. Okay, that makes sense. If x is 1, then we've raised the price $10 and we have exactly this scenario right here. So now let's try and generalize. The revenue is number of tickets times price. Or revenue would be 400 minus 10x times 300 plus 10x. And what's this going to give us? It'll give us, well, it already is a quadratic, but we can get it in trinomial form. Okay. This is going to be plus 4,000 minus 3,000. So that's plus 1,000x minus 100x squared. I really don't like seeing it in that form. So I'm going to put my x squared term first. Now I'm looking for the vertex. Okay, the x-coordinate of the vertex is at negative b over 2a, or negative 1,000 over 2 times negative 100. In other words, 5. So we could say the maximum price occurs after 5 $10 price hikes. This means a selling price of $350. That whole idea that the x-coordinate of the vertex is the axis of symmetry, or as negative b over 2a, can save you some trouble. We've got the question all done here. If you had instead been inclined to do it by completing the square, well, we can go through that. But we really don't need to here. So we'd take out negative 100 as a common factor. That would leave us with x squared minus 10x. Okay, I'm going to leave some space. Maybe I'll do these big square brackets. Plus 120,000. Okay, I need to take, 10x. I need to take half of the middle. So that's going to be negative 5 and square it. So that'll be plus 25 minus 25. I've got a perfect square trinomial, so I know it factors like this. And from there, I can just work my way through. Negative 100, x minus 5, all squared, plus 2,500, plus 120,000. Or maximum revenue is going to occur when I have an x value of 5. And the y value, or the actual revenue, is going to be 122,500. Again, not necessary, but gets you to the same place. I hope that you've found this helpful, and good luck with all of your studies.